Hi everyone, my name is Yifan. I did my research at MovieLens at the University of Minnesota. We did a field study of related video recommendations, so today I will talk about the results of our study as well as the implication of our results. So related item recommendation is a very important feature because it helps users find useful content. And a lot of websites use this feature in different ways. For example, the New York Times recommends related articles based on recency. Pandora uses a similarity-based approach, so it's recommending similar artists, for example, based on a given musician, using a non-personalized similarity-based approach. And YouTube not only recommends videos that are similar to a seed video, but their recommendations are also personalized to a user's preferences. Although there has been a lot of work that tries to design better related item recommendation strategies, there are relatively little work that compare existing strategies. So we are curious how different strategies compare with each other. And to explore this question, we decided to focus more specifically on related video recommendation. And we chose 3 algorithms to focus on. So our research question is, in related video recommendation, how do algorithms prioritizing recency, similarity, and predicted rating affect users' subsequent engagement? So now I've talked a little bit about our motivation. I will introduce our experiment and then discuss the results and the implication of our results. So we deployed 3 experimental algorithms on a movie recommendation website. And in addition to these algorithms, we also added a baseline strategy which randomly selects recommendations. And in each of our sessions, in each new login session, a user will be assigned with one of the 4 algorithms we're using to provide recommendations. And finally, we gather data for about 20 months. We launched our experiment on MovieLens, which is a site for helping people to find movies to watch. We chose this website because MovieLens runs MovieLens, so we have a lot of available data. And users on MovieLens can view movie trailers. So for the purpose of this study, we decided to use our algorithms to recommend related trailers to the trailer a user is watching. So now I will demonstrate what this experiment looked like for our user. Once a user clicks on Watch Trailer from the movie card, they will be directed to this trailer interface. The most important feature on this interface are the videos you can see at the bottom. The leftmost video is the seed video the user is currently watching. And all the other videos are the recommendations that our algorithms generate. And we track users' clicks on these recommendations. We also track how users interact with the current trailer they are watching. For example, would they wishlist the corresponding movie? Would they watch the next trailer? And how much of this trailer they've currently watched? The 3 experimental algorithms we're focusing on are similarity-based, recency-based, and personalized. All of these algorithms adopt a 2-stage process to generate recommendation candidates. So in the first stage, all of these algorithms identify 250 candidates by using a similarity, by calculating their similarity to the seed video that a user is watching. And these similarity between items are pre-computed and stored in our system. And you can read more about our technique here in our paper. And in stage 2, this algorithm ranked the candidates based on different criteria. So the similarity-based algorithm apparently ranked the candidates based on their similarity to the seed item, and it's non-personalized. The recency-based algorithm ranked the candidates based on their release date, and it's prioritizing the most recent ones, and it's also non-personalized. And finally, the personalized algorithm uses a MovieLens recommender which predicts a user's rating for a movie they haven't watched yet using item-item collaborative filtering. and then it ranked the candidates based on their predicted scores. It also blends in some item popularity to rank the candidates. So now I will introduce the results of our study. We gathered some descriptive statistics, such as the total number of users, sessions, trailer views, and clicks and recommendations. And using these statistics, we built mainly two metrics to evaluate our algorithms. The first metric is the click-through rate. What does click-through rate mean in our setting? So users on MovieLens can access a trailer in many different ways. For example, they can click on Watch Trailer on the movie card. They can play a trailer from the movie detail page, or they can click on one of the recommendations we provide on our trailer interface. So our click-through rate here is specifically measuring the ratio of clicks on these recommendations we provide over a user's total trailer views. And by using this metric, we found that the recency-based approach actually performs the best in terms of click-through rate, and is closely followed by similarity-based approach. And both of these non-personalized approaches did a better job than the personalized approach. We also built a statistical model which verified our result here. The second set of metrics we used are the engagement metrics. So the first engagement metric is called watch more than half, meaning a user watched more than half of a trailer, and it indicates the trailer is good enough to spend some time on. And the second metric is called wishlisted movies. And the engagement metrics evaluate the algorithms from a very different perspective than the click-through rate. While click-through rate is looking at how often users click on the recommendations from a higher level, the engagement metrics are looking at users' interactions with a recommendation after they've clicked on the recommendation. So it's looking at users' degree of interest in a recommendation. And using these metrics, we again found the recency-based approach performed the best. Although this time the similarity-based approach isn't as good as the recency-based approach. And we also built another statistical model that confirms our result. So how do we interpret our results? First, I'd like to give another brief summary of our results. In general, we found the non-personalized approach did a better job in terms of click-through rate, and the recency-based approach performed the best in terms of both metrics, and the similarity-based approach performed well in terms of click-through rate, but it's not so good in terms of engagement metrics, meaning it's not very good at finding content of high quality. And these results are a little surprising to us because MovieLens have been traditionally relying heavily on collaborative filtering, which is the basis for our personalized algorithm here, and that's why we expect the personalized algorithm to perform the best here. But in fact, the simpler recency-based approach did a much better job. But we do have some explanations. It might be that there are more efforts spent on recent trailer production, so they are more attractive, or users are specifically looking for trailers for newer releases. But we think the more important questions to ask here is whether the success of recency-based approach is domain-specific or not. Would it work well in news recommendation, as the previous speaker discussed? Or what about book recommendation and e-commerce recommendation? And it seems that recency can be an important factor in a lot of these scenarios. But can we consolidate our conjecture in the future? Is it possible to find out what specific characteristics of a problem might indicate the success of recency? Or to take this even further, can we find out what specific characteristic of a recommender system problem in general indicate the usefulness of different strategies, whether it's recency-based, similarity-based, or personalization? And we think that will be something interesting that future work can investigate. And finally, I'd like to thank my advisor, Dr. Harper, and University of Minnesota and NSF for supporting my research. And I'm happy to answer any lingering questions you might have. Thank you very much.
question here. So I'm a little bit surprised I found that your baseline, which is a randomized recommendation, actually is not that far behind. So do you kind of have any thoughts on why that's the case?
Yeah, so the algorithms we're testing in our experiment are all relatively simple. Like they are similar, the three of them are similarity-based, and then they rank the candidates based on different criteria. So for the baseline algorithm, we're looking for like a more, like an even simpler algorithm that's also different from our other approaches. And a lot of recommendation algorithms are using similarity-based approach, but we don't want our baseline algorithm to also use the similarity-based approach, because that way we can't really figure out what's the difference among them. And that's why we decide to use a much simpler random baseline.
Yeah, I understand the reason using randomized recommendation as a baseline. My question was more like, think about your candidates is about 250 movies, and you randomize them, so a lot of kind of shuffling permutation. So I would expect the randomized kind of baseline kind of performance is much less effective as compared to similarity-based, recency-based, and other personalized as well. But when I'm looking at your results, it's really not that far behind. It's quite close, even in one case. Yeah.
Are you talking about the?
Yeah.
The one here. Oh, yeah. So
So for many of them, it's quite. I just found it a little bit surprising for me. I was just wondering, have you put any thoughts? And it's like domain specific, or I don't know. Is that kind of something? Have you kind of a look? Like a deeper in the data, and why is that the case?
Yeah, I understand your concern here, and we think the reason why this pattern might occur is that, like, the number of people who wishlisted movie are only about 600. So the data we have are very small, and when we have small data, we might have the results might not be as reliable as we would expect. So yeah, I think the lack of data here might cause the pattern that you see that aren't that consistent with our other observations.
Okay, thank you.
Yeah.
So Chris is there.
Yeah, hi. Thank you very much for your very nice presentation. I have a question regarding your similarity-based approach. And the question here is, did you just try out one approach here? Or was it like that you were looking at the title, at the images maybe, also at genre, and so on, tried to combine that? Were there different results then? And what was actually the baseline here for the similarity-based approach?
I'm sorry, can you clarify your question again?
Yeah, so the similarity-based approach, first of all, what did you use here? What kind of features?
So for the similarity-based approach, we, let's see. So we used similarity that are between movies that are pre-computed in our system. And the way we compute the similarity is to use a algorithm called the tag genome. So basically, we have 250 tags that tries to describe a movie's content, and we describe each of our movie in like a vector of 250, and we compute the similarity between the vectors to figure out how similar two movies are.
Yes. So, but then you can also use other features, like for instance, the title, string distance, right? Did you also try this out, maybe?
Yeah, so we didn't consider title or, we didn't really consider title, but we did consider some other factors, such as popularity. Yes, I remember we have some other elements, but I couldn't recall it, but I am happy to talk with you. And we actually included a lot of these other factors in our statistical model. For example, we have a table here that shows some significant factors, like like the position of a recommendation actually plays an important role. And so here we have popularity, but we also, so in several other models we built, we also consider like their popularity and their ranks of popularity in our system, and we didn't find significant effect of those variables, and that's why I'm not presenting them in my talk.
Okay. Yeah, thank you very much. I'm looking forward to talking with you later.
One more question, Malendra here.
Okay. So the thing is here, in your data, you considered the different trailers, right? So what is your take? Suppose your data changes from the trailers to certain other things like music videos where people repeatedly consume quite a lot versus movies which are of larger length and user has to spend a lot of time and energy to see that. So when the data changes across these domains, under the same video domain but the different subdomains with different characteristics like this, do you feel that the same observations that you have here will be translated or transferred to that, or there will be some changes?
Yeah, I really like your question about like how this result can differ from domain to domain, and I don't personally have like an answer for that right now, but we are definitely curious to see how these apply differently in different domains.
Okay, all right.
Yeah, sorry about that.
It's okay.
Okay, let's thank our speaker. Remember that there is a